So what happens when we truly make contact with the ETs? The United Nations, they're considering that right now. They're working on a plan. Up next, physicist Dr. Michio Kaku on Coast to Coast AM. And welcome back to Coast. I'm George Norrie. Dr. Michio Kaku, theoretical physicist, best-selling author, television host, radio host. He is the co-founder of the string field theory. We'll talk about that later tonight, and continues Einstein's search to unite the four fundamental forces of nature into one unified theory. Here's Dr. Michio Kaku. Michio, I think I'm in your neck of the woods, aren't I?
That's right, Manhattan. That's where I hang out.
I should send a car to pick you up and bring you down to WOR while you're on the phone with us or something. It's good to talk to you.
2 o'clock in the morning.
That is. How are things?
Very good, very good. Mm-hmm.
The radio show's going well for you. The TV programs are going well for you. And I think you've got a new book coming out in March of next year called Physics of the Future. What's that going to be about?
Well, it's about the next 100 years. It's perhaps the most ambitious book that I've ever written. I did a previous book called Visions, where I talked about the world 20, 30 years in the future. But my publisher said, let's go for it. Let's go for 100 years in the future. This is what Jules Verne did, by the way, in 1860, during the time of the American Civil War. He wrote a book called Paris in 1960. And believe it or not, H.G. Wells, during the time of the American Civil War, predicted that Paris would have skyscrapers, it would have gasoline-powered automobiles, it would have something like the Internet, and it would have a lot of the modern conveniences that we associate with society. And he got it right on the button. It's amazing. He predicted what Paris would look like 100 years into the future. So I took that inspiration to try to project what our society would look 100 years in the future.
There was an incredible story about the United Nations Office of Outer Space Affairs. You were on Fox News just a few hours ago, in the wee hours, reacting to this. They're considering setting up protocols for when we finally make contact with extraterrestrial life. What the heck are they working on, Michio?
Yeah, well, at first it sounds like a goofball idea, right? But then you begin to realize the logic behind it. You're right. It is the United Nations Office of Outer Space Affairs, and its director, Mazlan Othman, has been going around saying that the United Nations is considering setting up the protocols for when we make contact with extraterrestrials. Now, the justification is that so far we've seen about 500 planets circling other star systems, but these are Jupiter-sized planets. But in the coming months, the results of the Kepler and Koros satellites will be announced, and the betting is among astronomers that when the press conference is finally unveiled, we will locate maybe scores of Earth-like twins in outer space, planets that look very, very similar to us. So when we look at the night sky, we'll wonder whether or not anyone's looking back at us from these Earth-like twins in outer space. Therefore, the United Nations says, let's start thinking about the protocols when we do make contact with extraterrestrials. Sounds pretty ambitious to me.
Well, you know, Michio, so many things, Dr. Kaku, have been going on over the last several months. The Vatican continues to talk about extraterrestrial life. Now they're talking about their head astronomer wants to baptize the ETs. SETI continues doing what it's doing. Do you think there's truly something happening here? There was a news conference at the National Press Club today where 6 former military experts who were watching our nuke sites have claimed that UFOs have shut down some of the sites over the years. It just sounds like there's something going on here. It just, things seem to be building. Is that a pretty accurate perception?
I think so. I mean, people's attitudes are also changing dramatically. Just realize that back in 1600, Giordano Bruno was burned alive in the streets of Rome by the church for saying that there's life on other planets. And now the very same Catholic Church, instead of burning people alive, is trying to embrace the possibility that, yes, maybe we will make contact with extraterrestrials. Now, however, to be fair, when the United Nations made that announcement, certain astronomers pointed out the difficulties involved. One difficulty is that if we eavesdrop on conversations among alien civilizations in space, they'll be so far away that it would be a one-way conversation. We can hear them, but if we send a signal to them, it won't reach for many a decade or maybe centuries. So it'll be a one-way conversation for a while, unless, of course, they land on the White House lawn. And if they land on the White House lawn, then, of course, we'll make direct contact. And then, of course, protocols are necessary. How do you address them? What do you call them, Mr. and Mrs. Ambassador, or do they even have Mr. and Mrs.?
What do you think are the strong possibilities of ET life out there?
Well, I do think that, again, in the next few months, maybe next year, we will announce that we have found Earth-like twins in space. At that point, the SETI project will focus its effort on the handful of star systems that have promising Earth-like candidates, and will then concentrate the effort there instead of scattering out looking for, like a fishing operation, trying to find signals from random stars. Why not focus on those solar systems that already have Earth-like twins? And then when that happens, there is a fighting chance that we'll eavesdrop on alien conversations. And when that happens, we have to then figure out, who are these people? I mean, how advanced are they? I personally think that we should not send a signal to these planets until we know what their intentions are, whether they're hostile or benign. Who knows? Look what happened to the Aztecs when Cortez came.
That's right.
Within a matter of months, he destroyed the Aztec Empire.
Stephen Hawking has that same view as you. He doesn't think we should make contact because of that very reason.
Yeah, well, I think we should make contact, but first we should figure out what their intentions are. And first we should figure out how advanced are they. Are they type 1, type 2, type 3? If they're just type 1, perhaps they could be ferocious and savage, but they're probably not that advanced. By the time they're type 2, they probably are benign, and they're stellar, and they're very much like the Federation of Planets on Star Trek. By the time they're type 3, they're galactic. And at that point, there's really not much we can do if they decide to invade us, if they're type 3. However, I would also assume that they're benign, and that there are plenty of planets that have minerals that are uninhabited that they could take. Why bother to take the Earth with restive natives when there are plenty of planets that have nobody on them at all, with plenty of natural resources? So I don't think we're going to have any hostile aliens to worry about. But just in case, I think we should observe them first before we send a message or send a rocket to intercept them.
If we find a planetary system that is older than ours, older than 4.5 billion years, could we assume, if there's an Earth-like planet there, that they might have life? Is the soup the same, Dr. Kaku, where everything should develop, in theory, if things are all the same?
Well, we do know that the amino acids, the precursors of the proteins that make our body, they are found in meteorites. They're found in gas nebulas when we look in outer space. Pretty much everywhere we look, we find evidence of the building blocks of life spontaneously forming because carbon has 4 bonds and loves to form carbon chains, and amino acids are very simple carbon chains. However, DNA is a whole other question. DNA is, of course, the molecule of life, but it is extremely complicated, and it's not clear whether alien life will have the same DNA as ours. And it may be possible that there are other molecules besides DNA, which can reproduce themselves, because that's what DNA does. Once you have one molecule, you have 2. Then once you have 2, you have 4, 8, 16, 32, and pretty soon you take over the whole planet. So it's not clear whether they're going to have the same DNA. And so some people say, well, how do you know if aliens are not already here? One thing you have to do is, if you can find alien DNA, that would settle the question right then and there. End of story. You know, you don't have to have Air Force pilots saying that they intercepted a UFO over Tehran or over Belgium. If you have alien DNA, that ends the question right there.
There's a project called the Star Child Project, which is really not a child at all, but it's a skull of an elongated entity, creature, maybe human, but our guest, Lloyd Pye, believes that it is extraterrestrial. They are working on DNA on this finally. And, we'll get the results eventually. But you're right. If it shows that it's not human, it's dramatic.
Yeah, I'm a scientist, right? So instead of speculating and wondering and scratching your head for years and years, why not settle the question? If somebody could have an alien chip that fell off a UFO, that too would settle the question. Alien DNA, alien chip, any tangible piece of evidence, end of story. That would settle the question right there if someone could ever obtain that stuff. And
What's new with the... I'm sorry, go ahead.
Yeah, go on. So what I'm saying is that we physicists and astronomers, we're trying to do it the hard way by looking for SETI in outer space, looking for signals from planets, and we could very well in the coming decades find that, because we'll focus our efforts because we'll find the Earth-like twins. However, a shortcut would be if you could find evidence of visitation, if you could find concrete evidence, an alien ship, an alien DNA, that would settle the question immediately.
What's new with Sci-Fi Science?
Well, the Sci-Fi Science is the program I host on the Science Channel, and it immediately became the #1 program on the Science Channel. So now we're in second season. In an age when cable television has very few programs that go into second season.
That's fantastic.
Yeah, we're in second season now. And just last week, we did a whole half-hour program about what happens if the aliens are hostile. Personally, I think that the aliens will not be hostile. Personally, I think that they'll have had thousands of years to iron out all their religious, sectarian, racial differences.
Gosh, I hope you're right about that.
Yeah. However, there's always a small chance that they're not. So in last week's episode, we talked about what happens if the aliens are hostile. What can we do? Now, Hollywood seems to think that it's going to be David versus Goliath, like in Independence Day. But I think it's going to be more like, Bambi versus Godzilla. Initially, we're not going to stand a chance. But that's when we have to use our smarts. That's when we have to realize that if they're that advanced, and they are hostile, assuming they are, and they do take over the Earth, we're not going to be able to stop them. But that's when the battle begins. That's when we start to figure out their weak spots. That's when we start to regroup. That's when we start to figure out how to take them down. But again, that's hypothetical. Personally, I think they're going to be friendly, they're going to be benign, but probably they may not be interested in us. Why should they land on our White House lawn? If we're so primitive, if we're like ants to them, they may not want to visit the White House.
Well, and if they just see the things that have happened on this planet, Dr. Kaku, over the years, I'd stay away.
Yeah, it's like an anthill. If you go down a country road and see an anthill, do you say to the ants, "I give you trinkets, I give you beads, I give you nuclear energy," or maybe you just walk away or step on a few of them? So I would assume that if they're that advanced, if they're Type 3, that is, they're galactic, and they roam the galactic space lanes, we're rather primitive to them. In which case, they'll probably just want to leave us alone.
What's new in the world of science out there with CERN? You've been following that. Have they found the God particle yet? Are they getting any closer?
Well, yeah, the CERN machine, the Large Hadron Collider, is our baby. It's the machine that we created, and we hope to test string theory with the machine. We hope to create what is called dark matter. And if we can create dark matter, that would send shockwaves throughout the whole physics community. Now, if we find the Higgs boson, the so-called God particle, that would not upset physics so much because we all believe it exists. It's the last piece of the jigsaw puzzle for the standard model. But the standard model of particles, which contains quarks, neutrinos, and electrons, is one of the ugliest theories known to science. And it's hard to believe that Mother Nature could create a theory so ugly at the most fundamental level. That's why we assume that this so-called standard protons or whatever, that this standard model is really the lowest vibration of a string. And that would be the most elegant, most beautiful way to summarize this ugly theory called the standard model, which we are testing with this $10 billion machine.
I can't tell you, Dr. Kaku, how many people have come up to me just in the last few months with this question that we all try to answer. Why are we here? Who are we? What is it all about? How does science look at that question? Because, assuming there's more to life than what we think, how does science look at the question of just why are we here?
Well, Stephen Hawking, my colleague, wrote a book that, while he was on the Larry King show, he's been doing a lot of interviews because the book is about purpose. Does the universe have a purpose? And just so I give you the conclusion of the book, he says that the theory of everything is probably string theory, which is what I do for a living.
Right. Yeah, we had his co-author on who basically paraphrased and said that he didn't say there's not a God, but he's not saying God created the universe. Well, the book seems to indicate, I have a copy of the book. The book concludes and says that, the theory of everything is most likely string theory. String theory, in turn, gives you a multiverse, a universe of soap bubbles, where bubbles pop into existence and create other bubbles. Therefore, he says, and this is the big conclusion that the media then pounced on, therefore, you don't need a God. Not that God doesn't exist, but you don't need him because these universes create baby universes. And baby universes create grandbaby universes. And these bubbles percolate and bump into each other and create other bubbles. And you have the constant creation of universes. So parallel universes, just straight out of science fiction, straight out of Star Trek, are being created even as we speak. And therefore, we don't need a creator. So that's what generated all the publicity. My attitude is a little bit different because my question is then, well, where did string theory come from? Exactly.
I mean, if string theory is the architecture that gives you self-perpetuating parallel universes, and I write about this in a previous book of mine, Parallel Worlds, then where did that theory come from? And this is what Einstein grappled with. Einstein knew that there was this theory of everything, but then he asked an even deeper question. Why should it be that way? And therefore, he was led to God. That is, he was led to the God of harmony, the God of Spinoza, the God of Leibniz, that the universe was so beautiful. It didn't have to be that way. It could have been random. It could have been ugly. And here we have this gorgeous theory, the theory of music. I mean, who would have thought that the universe could be explained in the language of music?
True, yeah.
That it was too beautiful to have been created as an accident. So, again, we have two different points of view, one taken by Stephen Hawking, who says, therefore, we don't need a God. Maybe God exists, but we don't need him. And then we have Einstein's point of view, who says, now, wait a minute, not so fast. Where did the theory itself come from, right? And that's why Einstein was led to religion, or at least to think about the whole question of a creator and beauty, elegance, simplicity in the universe. So it's a rather sophisticated question.
Of those two paths, which one do you go down?
Well, I think Einstein was really onto something because he knew that there was a theory of everything. He just couldn't find it. You know, he spent 30 years of his life chasing after it.
Frustrated, probably, yeah.
Right. But he asked then the next question, that let's say he did find it, then why this theory? He said when he woke up in the morning, Einstein would say, the first thing he asked himself is, if I am God, if I'm a deity, and I'm creating a universe, why this universe? Why not another universe? Why not an ugly one? Why not a stupid one? Why not a random one? Why this one? And he said, that's the question of all questions. Why this universe?
Let's find out more about this. This is fascinating. We're with Dr. Michio Kaku right here on Coast to Coast AM's website, linked up at coasttocoastam.com. We're live from WOR in New York, and we will be right back with our very special guest tonight, Dr. Michio Kaku. Hey, by the way, are you a member of Streamlink? Are you a Coast Insider? You can be for just pennies a day. Get your downloads, podcasting, iPhone apps. Very soon, as we get into October, Android and BlackBerry apps as well. It's just a great way to be a part of Coast to Coast AM. When we come back, we'll continue our discussion with Dr. Kaku on Coast to Coast AM. Oh, with Dr. Michio Kaku. Michio, let's continue this Einstein story. This is incredible stuff. I mean, I did not know that he was a believer in, I would say, the godlike possibilities. Did that happen later in his life?
Oh, no. He, throughout his career, he wrote about the old one. That is, he believed that the laws of physics were so gorgeous, so simple, that there had to have been a design. And he talked about being like a child going into this huge library, this gigantic cavernous library, and that we, as humans, could only take the first volume of the first page and read just the first page of this gigantic library. And that's how we were just beginning our quest to understand the laws of nature. And also, by the way, if people want to know more about my views on these things, you can check out my website. It's mkaku.org, mkaku.org, mkaku.org. You can follow me on Facebook, and also I have a blog on bigthink.com.
Well, I'm glad that since you've been on with Art over the years, Michio, you're getting that kind of exposure now and recognition that you deserve, and it's refreshing to see your career grow too.
Well, thank you. And like I said, the sci-fi science on the Science Channel, that's been a real experience, not just being interviewed by TV or radio, but actually hosting. That's a whole new world when you are hosting, because you have to do so many new things. One episode, I had to swim with dolphins. We had a program about, what happens if we make contact with alien life. Will we be able to communicate with them? Well, can we communicate with our own creatures on the Earth, like dolphins? Are there computer programs that can crack the language of the dolphins? So they put me in a swimming pool in SeaWorld, and there I was swimming with dolphins. And then we had another episode about shape-shifting, like Transformers or the X-Men. And so I had a chance to shake the hand of an octopus, a live octopus, which is nature's shapeshifter. And so, hosting sci-fi science on the Science Channel, I get to do all sorts of goofy things to illustrate basic principles of
over there, and she was showing me one of your pilots with the Star Wars swords.
Mm-hmm.
And she said, "This is going to be a hit, isn't it?" And I went, "You got the right one for it." And and lo and behold, there it is. What's new with science, Michio, these days? What are they coming up with that we don't even know about yet?
Well, there's so many things happening. It's just a question of picking which field. For example, in physics, invisibility has rocked the whole field, turned the whole field upside down. It's embarrassing. I used to teach optics and tell the students that invisibility violated the laws of optics. You could not get Harry Potter's invisibility cloak. And then I would give the equation. Well, I was wrong, and so was every single physics textbook on the planet Earth. We now make objects invisible under microwaves regularly. And optical frequencies, we can make tiny objects disappear, and it's only a matter of time before we scale it up and make large objects disappear optically. And so this just goes to show that you never should say the word impossible.
And we're not talking about creating an artist image to paint where it looks like it's invisible. This is actual invisibility, isn't it?
This is a real McCoy. This is something straight out of Harry Potter. We're talking about creating a cloak. Actually, the simplest one would be a cylinder. Let's say you put a person inside a cylinder. Light hits the cylinder, wraps around the cylinder, and then reforms at the other end. Think of a boulder in a stream. If you're downstream from a boulder, upstream, you don't know that there's a boulder there because the water reforms as soon as it wraps around a boulder, right? Same thing here. If light were to wrap around your body, somebody looking at your body would see what's in front of you. In other words, right through you. So you'd be invisible. This is the real thing. This is something straight out of science fiction.
I mean, the applications for this would be absolutely astounding, wouldn't
Well,
it?
of course, let's be frank about this. The military is funding a lot of this research. I mean, they're not stupid. Think of the possibilities of invisible tanks. The military spent billions on stealth bombers, and they're not even invisible. stealth bombers can be seen by radar. And I was on the Stephen Colbert show a few months ago, and he asked me, well, where, if time travel is possible, and you physicists seem to think so, then where are the aliens from the future visiting us? And I said to him, well, look, maybe they're invisible. We will have invisibility long before we have time machines. And so maybe they're already here. Maybe they're simply invisible.
Tell me about the discussions of the multiverses, Michio. You know, for years we always assumed our universe was it. And now there could be many, many more universes out there.
Right.
If so, what could they look like too?
Well, when you say the word universe, you automatically have a prejudice that there's one world. So that's why we use the word multiverse. Now, string theory introduced the concept of multiverses back in the 1970s, 30, 40 years ago. However, people laughed at it. People said, beam me up, Scotty. This is Star Trek. This is not physics. Well, they're not laughing anymore because string theory has pretty much taken over the field of theoretical physics, my field, and you can't move without bumping into somebody who's desperately trying to learn string theory or has mastered the art. And these other universes could be quite different than our universe. They could exist in different dimensions. They could have different particles, different states of matter, or some of them could look just like our universe, except maybe one little tweak difference. Let's say a cosmic ray went through Hitler's mother. Then maybe Hitler's mother was never born. I mean, Hitler was never born because the mother had a miscarriage. One cosmic ray, one quantum event can separate two universes, one universe where there was World War II and another universe where there was not World War II and 60 million people didn't have to die. I mean, these are staggering possibilities. So no one's laughing anymore. We take this very seriously. And so, with the Large Hadron Collider outside Geneva, Switzerland, we're going to try to test this theory. So we're way beyond simply having dinner table conversations about whether or not Elvis Presley is alive in another universe. Well, maybe he is alive in another universe. We're now creating machines which can test these things. So that's how far we've come.
Would these multiverses be hooked together like bubbles, or would there be gaps in between them?
There would be gaps in between. If you think of a bubble being a universe, the skin of the bubble is our universe. So everything that we see and love and cherish is on the skin of this bubble. The bubble is expanding. That's called the Big Bang Theory. But then people ask the question, if the universe is expanding, what is it expanding into? What is expanding into, we think, and of course we want to prove this later, what we think is expanding into is another dimension. So if you're like a bug on a balloon, and the balloon is expanding, you would say that the balloon is the universe. The balloon is everywhere you can move. But where are you expanding into? You're expanding into the third dimension. So we think that maybe we're expanding into the 11th dimension, that the arena, the true arena of the universe is 11-dimensional, not 3. We live on a 3-dimensional bubble floating in 11 dimensions, and there are other bubbles out there. These bubbles can pop into existence. They can touch each other, bump into other bubbles. And when two bubbles collide, that causes a titanic explosion, which could be the Big Bang.
That could be. That's a good point.
Yeah, the Big Bang could be the collision of two bubbles or the popping of a bubble into existence or the budding of a bubble from another bubble. So we have continual creation, and we're going to test this theory. We're sending up satellites to test what is called inflation. Inflation is a theory of constant genesis, continual genesis, and the latest data seems to say that inflation theory is correct. So, for those people who think that there's only one universe, that's very quickly fading as a theory.
It's gone.
So get used to it. The data seems to support a multiverse. Doesn't prove it yet, though.
Why can't we see them?
Well, if you're a bug on a balloon and you can only see on the skin of the balloon and wander along the skin of the balloon, you're like, fly on flypaper. You're stuck. But there could be other bubbles out there. Now, gravity, on the other hand, freely goes between bubbles. So some people think that we may be able to detect the presence of these parallel universes because we can feel their gravitational effects. If there's a nearby bubble, like a nearby galaxy, it would have gravity. We would feel the gravity, but it would be invisible because it's hovering above us. Now, doesn't that sound like dark matter?
It sure
Some people
does.
think that dark matter is ordinary matter floating above us in another dimension. Now, if that's true, that could explain the mystery of dark matter. Now, for those of you who don't know, dark matter is invisible matter. We know it exists. The Hubble Space Telescope has given us gorgeous maps of dark matter, but it's invisible. It has weight. If you held dark matter in your hand, it would filter right through your skin and your bones because it doesn't interact with your skin or bones. It would go right through the crust of the Earth, right to China, reverse direction at China, come back toward you, and then come right back into your living room. And then would oscillate between your living room and China as if the Earth weren't there, except, of course, it has gravity. So dark matter is pretty bizarre stuff.
What's its purpose?
Well, it holds the galaxy together. Some people say, well, why bother with this theory? This is the reason why we exist. In other words, people have often wondered what condensed the Milky Way galaxy. We had a big bang, all this fluff blasting out in all directions. Why did the galaxies condense? Why did they spin so fast? We think that dark matter condensed first. We think that the clumpiness of the universe took place because dark matter, this invisible matter, clumped first. And later, ordinary matter began to be attracted, and that created the Milky Way galaxy. So the very fact that we're here having this conversation is because of dark matter.
Yay, dark matter.
Yeah, and we hope to create it with the Large Hadron Collider. That's the betting. The betting is that we'll be able to create our own dark matter with the Large Hadron Collider. And again, it's harmless. You don't have to worry about it because dark matter you can't even contain it. It just flies through everything. And once we find it, then we'll say, aha, string theory actually predicts dark matter. And then that's another way to test string theory, by creating new particles that string theory predicts. Now, in string theory, we have something called sparticles. Sparticles represent the next highest vibration of the string. We're the lowest vibration. Think of a whole bunch of rubber bands vibrating. That's us. We're nothing but a collection of rubber bands vibrating. These rubber bands are called electrons, neutrinos, protons, quarks, but they're all in the lowest frequency. But if you can vibrate them at a higher frequency, they become sparticles, and they become invisible, just like dark matter. So dark matter could be nothing but ordinary matter in a higher octave. This is exciting stuff.
When do we master the ability to travel through wormholes so we can go throughout the universe in an instant?
Yeah, well, that's tough. Okay, first of all, Stephen Hawking has created certain theorems, very, very powerful general theorems using Einstein's equations, about what it would take to open a gateway, a porthole, a hole in space and time, just like Alice's looking glass. And what would stabilize it? What would keep the looking glass open so that you can fall through? Now, it turns out that black holes do this normally. At the center of a black hole, at least the mathematics shows that a spinning black hole, for example, collapses to a ring, not a dot. The textbooks get it wrong. The textbooks say that black holes condense into a dot. All black holes are spinning very rapidly that we observe with the Hubble Space Telescope. Therefore, they collapse to a ring, not a dot. And if you fall through the ring, there is a theory that says that you follow the looking glass into Wonderland. So the looking glass of Alice is a black hole. The rim of the looking glass is the spinning ring, the black hole itself. And if you put your hand through the ring, your hand is not crushed, your hand is not destroyed, your hand winds up on a parallel universe. Then the question is, you ask a question, what would it take to fall through one of these things? Okay?
And control it.
That takes a new form of matter to keep the gateway open before it closes. Now, this means that you need something called negative matter or negative energy. This is not dark matter. This is not antimatter. This is something new called negative matter, negative energy. it would hold the gateway open so that you can fall right into Wonderland.
Almost like a foot in the door, huh?
Foot in the door. It would keep this ring from collapsing on you. It would create what is called a stable wormhole. Now, we've never seen negative matter. Negative matter would fall up. It would have anti-gravitational properties. If it existed once upon a time, it would leave the Earth because it is anti-gravitational. It's repelled by the Earth. So we don't expect the Earth to have any negative matter. If there's negative matter, it's in outer space. Now, if you're a Star Trek fan, you know that there's something called dilithium crystals. The dilithium crystals allow warp drive. Well, to a physicist, there's no such thing as dilithium crystals. What we talk about is negative matter. Negative matter would have the properties of dilithium crystals. It would hold the gateway open sufficiently so that you can fall through the gateway and not be crushed.
That would be magic if that could happen.
That would be magic, of course. Now, of course, we do not have rocket ships capable of harvesting negative matter in outer space, like a negative matter asteroid. But, you know, a Type 2 civilization, similar to what you see in Star Trek, a Type 2 civilization is only a few thousand years ahead of us. They may be able to harvest dark matter, not dark matter, negative matter that is floating there, just like in Star Trek. They look for dilithium crystals on different asteroids and planets. And if they could do that, that would then keep the gateway open.
If we are being visited by extraterrestrials,
Mm-hmm.
do you think they're using that form of travel and propulsion to get here?
Well, you know, if you talk to an astronomer and you ask them about UFOs, you get what is called the giggle factor, right? Their eyes roll to the ceiling and they say that stars are so far away that aliens could never reach us. It would take centuries for them to reach us. Well, that assumes that they're only Type 1. That assumes that they're only 100 years ahead of us.
That's right.
Yeah, a civilization 100 years ahead of us cannot reach us. Even us, our civilization 100 years from now would not be able to freely go between the stars. But now close your eyes and visualize a Type 2 civilization that's thousands of years ahead of us. And they can manipulate stars. Stars are their plaything. Their backyard consists of stars that they play with, like the Federation of Planets in Star Trek. Or maybe they're Type 3. If they're galactic, they can basically roam the galactic space lanes. At that point, they may be able to harvest negative matter in the universe to stabilize wormholes, in which case it's conceivable that they could create warp drive or wormholes and stabilize them. A whole new realm of physics opens up.
How exciting would that be, Michio?
Well, like I said, if we were ever to meet a Type 2 civilization or a Type 3 civilization, they would have access to energies we can just barely conceive of. The next big energy scale is called the Planck energy. The Planck energy is the energy at which space and time become unstable. It is 10 to the 19 billion electron volts. It is a quadrillion times more powerful than the Large Hadron Collider. So if you could heat up space and time to the Planck energy, bubbles would form, gateways to parallel universes.
Michio, when we come back, we'll talk about teleportation and time machines. And then later on, in our last hour, phone calls with Dr. Michio Kaku, right here, live from WOR in New York. I'm George Norrie. This is Coast to Coast AM. And our special guest tonight is Michio Kaku. You remember the movie The Fly, the Brundle Fly? Well, we're going to talk about teleportation in just a moment on Coast to Coast AM. And welcome back to Coast to Coast. I'm George Norrie. We're live at WOR in New York with our special guest tonight, Dr. Michio Kaku, physicist, time machines, teleportation. I keep thinking of that movie, The Fly, and how the fly got mixed in with the other human, and poof, we had a disaster. Are we teleporting now, Michio? Are they working on anything? I know that, I guess they're doing it with little particles, but are they getting to the big stuff yet?
Not yet. However, we are making enormous inroads on these particles. We can now teleport photons, particles of light, right across the Danube River. Eventually, we'll teleport into outer space. We'll teleport perhaps from the Earth to a satellite or maybe the space station, maybe even to Mars once we go to Mars. So there's no limit to where we can potentially teleport. We've teleported cesium atoms, rubidium atoms, but so far just atoms. Eventually, we'll teleport molecules, perhaps carbon dioxide, perhaps H2O. That's still a little bit in the future. But we can dream about the day when perhaps we'll be able to teleport organic materials, living things, maybe even people. But then that raises the question, if you teleport somebody, you have to destroy the original in order to recreate them on the other room. So who is this person over there? You've just seen the original die, and his soul went to heaven, maybe. But hey, if this guy went to heaven, then who's this imposter over there who has all the memories, has all the personality quirks, and he says, no, I'm Captain Kirk. It really raises philosophical questions of who are we? Are we just information if you can zap information across the room? It really raises all sorts of theological questions.
I am convinced that one day, if they can download memory to a chip somehow, and then they clone you, and they create this brand new Dr. Michio Kaku, this brand new George Norrie, and they put the chip back in, or they download the memory back into you, you will probably think you are the same you. And you'll be younger, healthier.
And live forever.
And in theory, live forever, because they can keep doing it. You go to a special store or hospital, and they download you again, and they upload you, and they put you in this younger body, and off you go again.
Yeah, personally, I'd like to live the old-fashioned way, but it's conceivable that if somehow all your memories and your neural circuits could be recreated, that you may be able to be reborn in a perfect body. Some people work in artificial intelligence theory, believes that one day we'll be able to create a robot body that's perfect, Superman-like, beautiful, gorgeous body, and somehow reprogram the brain so that it has our personality, or even download neuron for neuron, the architecture of our brain, into this other creature, so that neuron for neuron, transistor for transistor, its brain is identical to us. Now that, of course, is centuries away, but it really does make you wonder, who are we if, in some sense, we could be recreated somewhere else with all our memories? Who are we then?
Under teleportation, why do you have to break down, kill off literally the body in order to recreate and send it?
Well, this has to do with a bizarre aspect of the quantum theory called quantum entanglement. Einstein hated it, but hey, Einstein was wrong on this one. What can I say? We entangle electrons all the time. If you take two electrons and bring them together, they vibrate in unison because everything is vibrating. Then if you separate them, if you separate these two electrons, an invisible umbilical cord starts to form between these two electrons, so that if you wiggle one electron, then the other electron is also wiggled, knows that its partner is wiggling. Now, Einstein hated this idea, because if you separate these two electrons by a galaxy, so they're 100,000 light years across, and you wiggle one electron, then somehow the other electron on the other side of the galaxy is somehow aware of the fact that its partner is wiggling faster than the speed of light. Einstein hated this idea. But, hey, we measured this in the laboratory. In fact, with the film crew for the Science Channel, we went to the University of Maryland and actually photographed this whole process. We actually photographed what happens when you zap a cesium atom right across the room, and it materializes someplace else. We caught it on camera. Of course, it's a blip because on a computer screen, because their atoms were teleporting. But still, you can actually see the effect of teleportation right on the TV camera. So Einstein was wrong on this one.
So many new things going on with science, and they just keep getting faster and faster and faster. And I guess it just will never end, will it?
No, and we're just beginning, if you think about it. Like Moore's Law that says that computer power doubles every 18 months. That has given us the computer revolution of today, that your cell phone has more computer power today than all of NASA when it put two men on the moon.
Yeah.
And when you get a birthday card and the birthday sings happy birthday to you, that chip has more computer power than all the Allied forces of 1945, Hitler, Eisenhower, Churchill would have killed to get that chip. What do? You throw it away in the garbage. That's how powerful computers have become. We basically throw them away.
I remember Buzz Aldrin was telling me, Michio, that he needed to use a pen to stick down into a switch to get that lunar module up there so he can redock he and Neil Armstrong with the command module. I mean, it was just amazing when you think about that. And now some watches have probably more brain power than what they had in that thing.
Yeah. No, what you could put in a chip in a watch would rival anything that that NASA would have back in the 1960s. In fact, when you look at all these old tapes of them going to the moon, and you kind of wonder, how could an astronaut possibly get into a capsule knowing that he's backed up by a computer with the power of an old IBM PC of 1960s?
Well, that's why I think it would be so easy to get back to the moon because of the technology we have today. You know, we're not dealing with 1960 technology anymore. But they talk about another 15 years or 20 years. I don't understand why it would take so long.
The problem boils down to one word: booster rockets. We have miniaturized computers so that you can put 100 million transistors on your thumbnail. But booster rockets are booster rockets. The laws of gravity haven't changed at all. It costs $10,000 to put a pound of anything in orbit. That's your weight in gold. So think of Buzz Aldrin made out of solid gold. That's what it costs to just put him into outer space, just whipping around the Earth, spinning wheels, doing nothing. $10,000 a pound, the price of gold. So that's how expensive space travel is and will be for quite a while because of rocket fuel. That's the bottleneck. There's no Moore's law for rocket fuel. So space travel will be expensive until we get space elevators, until we get new forms of thrust. Then things start to change. But a space elevator is maybe 100 years away still.
Stephen Hawking says that in the next few hundred years, we have got to leave this planet if we're going to survive. You agree with that?
Well, in some sense, it's a law of physics that we're doomed. In 5 billion years, the sun will die. That's the outer limit of how long we can stay on the Earth. One day, the mountains will melt. The sky will be on fire. The sun will expand until the sky is on fire, and the oceans will boil, and we will go back into the sun. We came from the sun, and we will go back into the sun in 5 billion years. But even closer, we have other dangers. We have an ice age coming, perhaps in another 10,000 years or so. We have meteor impacts that could kill life on Earth on a scale of once every maybe 100 million years. And then we have the planet killer. The sun itself will eat up the Earth in 5 billion years. So it's a law of physics that the Earth is doomed. So at some point, we have to leave the Earth. Carl Sagan said we should become a two-planet species. Just have an insurance policy. Life is too dangerous to put on just one planet.
So where do we go? The closest is Mars.
Yeah, because Venus is too hot for us to live on. It's 900 degrees on Venus, and Mars is a frozen desert. But to terraform Mars, we had a whole episode on Sci-Fi Science about terraforming Mars. That'll take centuries, but maybe on a scale of millennia, we have to do it. Not anytime soon, but one day we may have to take Mars and make it into a Garden of Eden by creating a greenhouse effect, creating an artificial greenhouse effect on Mars.
Is it doable?
It's doable several ways. First, you can inject methane. Methane may exist naturally on Mars. We just have to harvest it, release it. Methane is a greenhouse gas. Another possibility is to deflect comets. Once we master the art of riding comets, we can deflect them and have them gently circle around Mars, disintegrate in the atmosphere to create rain clouds. And so, some ambitious people have even suggested detonating hydrogen bombs on the ice caps to melt the ice caps. However, then, of course, the water becomes radioactive, and that's not a good idea. But there's a lot of ideas being proposed to one day perhaps turn Mars into a Garden of Eden. But again, we're talking about on a scale of centuries. It's not going to happen anytime soon.
What do you think happened to Mars, Michio? I mean, because it probably had maybe some of the things we had on this planet.
Yeah, in fact, there's a theory that says that Mars cooled off first, so it was tropical when the Earth was molten. So maybe DNA got off the ground first on Mars, and maybe a meteorite slammed into Mars, carrying meteorite rock to Earth, feeding the Earth. So maybe that's the origin of DNA. So maybe, some people say, if you want to see a Martian tonight, look in a mirror. We could be the Martians.
We could be. We could be.
You never know.
You've talked about the world of the Matrix. How close are we to building something like that?
Well, one of the great things about being a host on Sci-Fi Science on the Science Channel, which airs every Wednesday night, is that I get to visit military installations, scientific installations, and see the latest in technology like the holodeck and the Matrix. And
they actually want you to come in there.
They want me to come in with a TV camera. And
exactly.
I get to put on all the gizmos on my back and my helmet. I flew down to Fort Benning, Georgia, and flew down to Aberdeen Proving Ground in Maryland, operated by the U.S. Army, where they have something that looks very close to the Matrix. You're in a room with TV cameras and 360 degrees, screens all around you, and you're on a treadmill that is omnidirectional. Anywhere you go at any angle, the treadmill is so sophisticated it can move in 2 dimensions, not one, and you can then walk in any direction, and you're walking in place. Then you put on a helmet so the screen knows exactly where you are, and as you move your head, everything moves just the way it would do in reality. So if you are in a firefight in Baghdad, somebody's firing at you, you run, but then the scenery changes. And even if you crawl, even if you're on all fours, crawling on the ground, the scenery changes to compensate for that fact. So for all intents and purposes, you are in Baghdad.
How remarkable would that be?
Yeah, so in another demonstration, the dinosaurs were chasing me. You could create 360-degree dinosaurs and even ride on a dinosaur's back. You could even put your head in the mouth of the dinosaur. And this is the future of your living room. One day, this technology will be so cheap that you'll have this in your living room. Your game room in your basement or your living room will have 360-degree screens, sensors on your helmet. Everywhere you move your head, everything moves in 3 dimensions. You can run in any direction, and the scenery moves with you. That's pretty cool.
That would be one heck of a video game at home, wouldn't it?
Yeah. And then the question is, what about touch? I mean, can you touch things? Well, the answer is yes. There's something called haptic technology. Haptic technology requires that you put your hand on a bunch of needles, thousands of little needles, they're harmless, that are vertically placed. They're all parallel. And as you put your hand on these needles, the height of the needles changes. So you have the illusion that you're touching something with texture. So with a computer program, you can vary the height of each needle so that when you put your hand on these needles, you think you're touching leather, you think you're touching steel, and you can then have the illusion of bumping into objects in 3 dimensions. So even the sensation of touch can be duplicated this way. So, Matrix, here we come.
I believe that there are a lot of people who practice telepathy right now. Mm-hmm. But will it ever get to a point, Michio, where people can do it at will because technology has helped them?
Yeah, well, with technology now, we can actually use telepathy to read rudimentary thoughts inside a person's head. We do it 2 ways. One with EEG sensors. You have these little patches that you place all over the guy's head. Looks like something out of a science fiction movie. Or you put them in an MRI chamber. Already, some people claim that we can see lies being formed by the thinking brain, so you can use that as a lie detector. If you saw the movie Salt with Angelina Jolie, they actually had the CIA using this telepathy machine to read the mind of terrorists. However, I don't think we can do that quite yet. But in Japan, there's even a group there that wants to photograph a dream. At first, I thought, no way.
That's amazing. How would that work?
Here's how it works. it actually has had limited success. When you see a dot, that's like a pixel, that creates an image, an MRI image on the brain, one dot. Then if you move the dot, the MRI image of the brain changes. So if you move the dot at all places, you've now mapped every possible configuration of light, creating images, MRI images, on the brain. And so these subjects were then shown a U. A U consists of 3 bars of light, and each pixel corresponds to a pattern that is known by a computer. When you've shown this U of light, each pixel by pixel, it created the image in the brain that could be read by a computer. And the computer said, U. Now think about this. We know where you dream. The dream center is known, and we know how each pixel of light corresponds to an image of the brain. But images are nothing but pixels, right? That's all an image is.
That is amazing.
So in Kyoto, in Japan, they've already done this. They've already shown that in principle it does work. And so, just like in Total Recall, just like in the movies, one day we may be able to photograph images of the brain and maybe even project images into the brain, like a motion picture camera.
You might literally be able to give someone a dream.
That's right. And already in the laboratory, if you show somebody a dog or a cat, we can pick up the images on the brain using a computer to decipher the image. It's gibberish, of course, in the brain. And so the computer now can identify whether or not you're seeing a cat or a dog or a book. So we now get a dictionary. Every time you see an image, that image creates this counter image in the brain. Computers recognize that image. And so every time you see a dog, the computer says, oh, you're looking at a dog. So we get a dictionary, a one-to-one correspondence. Now, so far, it's pretty primitive. So far, we've only been able to do maybe 20, 50 objects. But the sky's the limit, okay? So, so this is already a form of telepathy. And at Brown University in Rhode Island, they've taken stroke victims, put a chip in the brain of a stroke victim, hooked that chip to a laptop, and then the person can control the cursor on the laptop screen by thinking about it.
Oh, that's remarkable technology.
These people are paralyzed. They cannot move. They're stroke victims, totally paralyzed.
What a gift from science. Michio,
and now
stay
they can
with
read
us.
email, play video games.
We're going to come back and let's take a few phone calls, and then we'll do it all of next hour as well on Coast to Coast AM. And again, our special guest tonight, Dr. Michio Kaku. His website, mkaku.org. When we come back, we'll take some phone calls, and then we've got a full hour of phone calls with Dr. Kaku next on Coast to Coast AM. Dr. Kaku, you can tell that you have fun with science. What are some of your favorite aspects of science?
Well, one aspect of science is interacting with the public. I'm on Facebook, and I'm on Twitter, in fact, and I get to answer a lot of questions that come. I can't answer all of them, of course. But when I was a child, I was so frustrated that I could not get a straight answer to any of my questions about the universe. My teachers would kind of like stare at me as if I was some kind of strange kid. And I went to the library, and there was nothing that could explain all the stuff that I knew was happening in the world of science. So I don't want young people to be frustrated like I was when I was a kid. And, being on Facebook and being on Twitter and having a website and even a blog, I'm on bigthink.com, allows me to interact with the people. And I think that's great.
Absolutely. And technology has made that happen in so many ways, not only for science, but social networking, which is getting huge. But it does make your job easier, doesn't it?
It certainly does, because we professors always complain that we're lecturing to 30 bored students. Well, now we can lecture to 100,000 bored people. But at least they have a choice of logging onto your Facebook site or Twitter site. And so I think in the marketplace of ideas, the best ideas will rise to the surface. And I think that's where we professors have to really try to engage the public.
Let's go to Sacramento, California. Eduardo, you're up with us on Coast to Coast. Hey, Eduardo, go ahead.
Hi, good morning, Mr. Kaku. I got a question. I don't know if you know about this case in Mexico City. It's contacted Carlos Diaz. he had a contact with this spaceship that it was made of plasma, and they did studies in I think like 14 different countries around the world. What is your take on the plasma chip?
Oh, when was this? Could you explain in more detail? I'm not aware of this one.
It's like Carlos Diaz. He was having contact in 1993.
Mm-hmm.
These beings that come from this galaxy, but the spaceship or the UFO, it was made of plasma.
Uh-huh.
It was not a solid like regular UFO. A lot of people see. This spaceship, it was made of plasma.
Okay.
Was it tracked by radar? Was it tracked by pilots? Was it seen by many eyewitnesses?
Yeah. Well, you can find it on YouTube, but in fact, Mr. Philip Corso, they interviewed him, and then he said that the plasma ship, the beings inside the plasma ship, they were part of the spaceship.
Uh-huh.
What would a plasma ship be, Michio, if one existed?
Well, a plasma is the so-called fourth state of matter. You know, you have liquid, solid, gas, and if you heat an object hot enough, eventually the atoms begin to disintegrate into subatomic particles, so they begin to ionize, and that's plasma. A lightning bolt is made out of plasma. The sun is made out of plasma. In fact, most of the universe is made out of plasma. Now, I'm not aware of this incident. However, I've looked at hundreds of UFO incidences, and the ones that are the hardest to dispute are the ones, for example, the sighting that took place over Tehran, Iran,
Yes.
the sighting in Belgium, and the sighting in Alaska with the JAL airplane. These are the hardest to dismiss because they're multiple sightings by multiple modes. If you have one person who says, Martha, look, up in the sky, I see something, well, what does that mean? It's not reproducible. We can't back it up. There's no radar sightings. However, these sightings that I mentioned, the sighting over Tehran, Belgium, and Alaska, they're extremely hard to debunk because we're talking about radar sightings, not radar echoes. We're talking about visual sightings. We're talking about scores of military people who will swear that, yes, they saw this thing. People on the ground, people in the air saw it, and jet fighters were even authorized to fire on the UFO, and the equipment jammed. So we're in a situation where we scientists are at a loss. We can't say this was a weather balloon. We can't say it was a radar echo. We can't say it was swamp gas, the planet Venus, the weather anomaly. You go through the usual suspects, and you realize it doesn't fit the profile. So these are the hardest to dismiss. But like I said, this Mexico incident I'll have to look at. I'm not aware of this one.
Well, and, earlier, a number of military officials, past and present, talked about how British and U.S. nuke missile silos were shut down by ETs, by UFOs that were spotted overhead. I mean, these are folks who work with the military on a regular basis, retired, many of them now. I don't think they're making these things up. Something's going on, Michio.
Yeah, and I think it's worthy of more investigation. Now, it may turn out that it is a weather anomaly. It may turn out that it's ball lightning or some bizarre phenomenon that we've never seen before, maybe a secret military stealth bomber that we're not aware of. It could be that, but maybe it isn't. I think it's worthy of scientific investigation. So I don't think scientists should just bury their head in the sand and say, the crazies are out there again. I think we should take them seriously because these are phenomena that are very hard to dismiss because it doesn't fit the profile of the usual suspects.
Lee is in Minnesota on the wild card line. Go ahead, Lee. Thanks for calling.
Hi, thanks, George. First-time caller. I'm listening to you for a long time.
Thank you.
Love your show. Love your show, too, Michio. I watch it every chance I can.
Thank you.
My question is, actually, I'm just asking you to comment, Michio, and George, on the pineal gland. They talk about that it produces DMT, which is a spiritual molecule. I guess that's what some people call it. And how that it's our own built-in access to other dimensions and that sort of thing. Just wondering if you could comment as to your thoughts on that.
Well, we've had some guests on for some time who have talked about the pineal gland and the incredible mystical powers that it possesses for the body. And some people have even gone as far as to say it's like an antenna to receive information from somewhere up there. Michio, have you looked at that yet on your sci-fi show?
Yes, I have. It turns out there are two ways of being able to access religious experiences through the brain. One is with an electromagnetic sender. You can actually activate a part of the brain which gives you religious feelings. You feel like you're in the presence of a spiritual being. In fact, Richard Dawkins, the famous atheist from Oxford University, he was actually placed in this chamber. He had electromagnetic radiation zapped into his brain to induce religious feeling. But afterwards he said, nah, he didn't feel like he was in the presence of God. The second way is what is called to induce epileptic lesions. Epileptic lesions sometimes take place with people in car accidents, disease, and these people believe that when things happen accidentally, that there's a purpose behind everything. If it rains, it means that somebody wants to punish you. If you fall down, it was meant to be. Everything that happens has a spirit behind it. And some people think that even religious people may have had epileptic lesions as a consequence. Some people have speculated that Joan of Arc may have had an epileptic lesion because you really do think you're communicating with God, a spirit, a higher being. Now, the Catholic Church was asked about this, and some Catholic theologians said, well, maybe God created us because it's a radio antenna to God. It doesn't prove that God doesn't exist. It means that God created us with this radio by which we can then have these religious experiences. Well, I don't know. All I know is that this is an area of scientific investigation, either inducing this effect using a radio transmitter, basically, or by analyzing people that have strokes, disease, epileptic lesions, which then induce this kind of feeling of being in the presence of a spiritual being.
Michio, give us a little physics lesson on your string field theory again.
Okay, well, let me tell you about what Einstein wanted. He wanted an equation 1 inch long that would summarize all the known laws of science, an equation 1 inch long. Now, E equals mc squared is 1 inch long, and it unraveled the secret of the stars. Why do stars shine? Because matter turns into energy via E equals mc squared. So he cracked one of the great mysteries of the universe, the energy source that drives the entire universe. Well, then he was after bigger game. He wasn't satisfied with that. He wanted another 1 inch equation that would summarize light, gravity, the nuclear force, everything, and he failed. Well, today we think we have the theory. The theory is called string theory, and it says that all subatomic particles are nothing but rubber bands. We think subatomic particles are dots because the string is very small. But if you vibrate the string at different frequencies, it changes. So if you twang an electron, it becomes a neutrino. If you twang the neutrino, it becomes a quark. So all the subatomic particles are nothing but different musical notes on a string. So the notes on a string correspond to all the subatomic particles. Physics is the laws of harmony of the string. Chemistry is the melodies you can play on these vibrating strings. The universe is a symphony of strings. And the mind of God that Einstein eloquently wrote about for 30 years of his life, the mind of God is cosmic music resonating through 11-dimensional hyperspace. So these are not ordinary strings. They're strings that vibrate in a higher dimension.
Truly remarkable how it took physics so long, but you were able to find it. Einstein has his thoughts. What's next, Michio? You know, how many theories are out there? And obviously, if we knew, we could tell you. We could tell that answer. But physics isn't over yet. I mean, what's the potential of new things being discovered?
Well, if string theory is it means that the search for the fundamental laws is over, but the search for applications of these laws is just beginning. If you see a chess game, you know, you look at it, you don't know how the pieces move, but after a while, you sort of figure out how the pawns move, you sort of figure out how the bishops move, you figure out the rules of the game. That chess game is Mother Nature. And we are the scientists looking at this chess game. But that doesn't mean you're a grandmaster. Just because you know how the pawns move, it doesn't mean you're a grandmaster. What we have to become is grandmasters of the chess game. And that process is just beginning. Now, some people say, well, maybe I don't like string theory. I mean, it's hard to test. Mathematics are very difficult. I've written 2 textbooks on string theory for PhD students. They're required reading in many physics laboratories around the world. But I'll be frank, it's wall-to-wall equations. You need 5 years of calculus to read my books. So some people say, well, maybe I don't like string theory. Give me an alternative. Well, there is none. All other alternatives have been shown to be incorrect. So this is the only game in town. Either you play this game or you have to create your own theory. But so far, nobody has been able to create a theory that can unite gravity with the quantum theory. This is the only game in town.
Tiffany is east of the Rockies in Charleston, South Carolina. Go ahead, Tiffany.
How are you, sir?
Good. All is well. Thanks.
Okay, this is my second chat with you. And I have a brother who's a physicist, but I am actually a Reiki practitioner. And recently I'm healing from Morgellons disease.
Okay.
And I have a child who's epileptic and autistic. So we were talking about you were talking about dimensions.
Mm-hmm.
And I know that he talks about, hello, doctor, you said 11 dimensions?
That's right.
Are you including 0?
Including time. Time would be the first dimension, and then we'd have 10 spatial dimensions.
Because I think it's 12-dimensional. Possibly.
Well, at Harvard, they are pushing something that is 12-dimensional. However, it seems to be equivalent to string theory, but it's still controversial. There's a 12-dimensional theory being pushed. It has 2 times rather than 1 time. But a theory with 1 time is only string theory in 11 dimensions.
And the other thing you were talking about, I call it the cosmic lattice, the string theory.
Mm-hmm.
And basically, it's like a spider web. When the spider moves, or when something moves, just like sound travels, there is a vibration.
Mm-hmm.
And if we have atoms within us, even so we're in 4D form, can't we vibrate those atoms within us to be 12-dimensional? So we can teleport ourselves, so we can travel through space and all of that.
Well, in principle, if you could somehow control the vibrations of the subatomic particles in your body, you would have the power of a god. You would have the power to manipulate matter, reform it, create new objects almost from scratch. That's if you could control the vibrations of strings or these vibrating particles. Now, we can't do that. The closest we can get to that dream is something called catoms. Catoms are tiny microscopic transistors whose charges you can manipulate, like a chip that is smaller than a grain of sand. If you can control the charges on that, then the charges can rearrange themselves, attract each other, and then you can create anything out of sand. The sand would be intelligent, consist of trillions of chips. Each chip then reforms, and you can create anything you want. This is the dream of what is called programmable matter, in which you can literally create matter to order by pushing a button. All the charges rearrange, and you can create something out of nothing. Now, Mother Nature does it even better by vibrating atoms. So you're right. If you could control the vibration of atoms, you could then reform matter to create pretty much anything you want. But we can't do that, unfortunately.
Michio, why would there be a limit to dimensions? If you have 11 or 12, why not 15, 40?
What happens is the theory becomes unstable. The mathematics collapses, and the theory then collapses down to 11 dimensions where the theory is stable. So you could write higher dimensional theories, but they're unstable. They collapse down to the stable universe, which is 11 or 10 dimensional.
These laws of physics, which seem to be the same throughout the universe and probably the multiverses, it has got to show people that there's got to be some intelligent design behind it. I mean, this could not be a fluke of nature or a random act. Do you personally, is it frustrating for you to try to get that answer too?
Well, that is the question of all questions. Why this theory and not another theory? Einstein asked a simple question. Did God have a choice? Was there a choice in creating the universe that we see around us? We think that maybe there was no choice, that string theory is the only theory that's stable. It has all the properties you want of a quantum theory of gravity. But then the question is, well, where did that theory come from? Why this theory and not something else? And that's where Einstein was led to become religious. He said, to the degree that he is religious, is the degree to which he is awestruck by the simplicity and the gorgeousness of the universe. Because the universe could have been random, as you pointed out. It could have been messy. It could have been chaotic, but it isn't. You realize that all the laws of physics that we know of so far can be placed on a single sheet of paper. A single sheet of paper. It didn't have to be that way. It didn't have to be that simple. So therefore, Einstein said there's a God. He called him the old man, the old one, something that set this whole thing into motion. He didn't know what it was. He couldn't articulate it well, but he said there is a God, the old one, that set everything into motion. Otherwise, it's chaos.
He knew something was there. Well, stay with us. We're going to come back with the final hour with Dr. Michio Kaku and your phone calls. I'm George Norrie, and we are live from WOR and the Big Apple right here on Coast to Coast AM.